Hello everyone, we will look today, like we promised in the last video, how to make our own editor for example the text in which are displayed in our tooltip. Let me first show you what we will implement today. When you remember in the last video, there was this feature with the tooltip, and so I was able to send items via the chat, and this is still possible, but I want to show you. First of all, there are two items, flower and test, which are currently defined. Test is a legendary item with the text we see here, and flower is a common item that we also have in our game. And if you enter an item that doesn't exist, there is just question marks. How to show the tooltip and everything we already discussed in the last video, but today we want to make it configurable so that we can add items or text for those items in the Unity editor. What we want to build is an item editor, which looks something like that, where we can click on the items and we can fill out the text that the game will use to display those items. This editor is written with the UI toolkit, and that's what we look into. But first of all, let's check some things out. First of all, how is this saved? And these are scriptable objects. Scriptable objects are pretty much like mono behaviors, but they don't need to be on a game object, but they are an object for itself. They can contain code and everything, but for us it's enough for them to describe the data that we want to serialize and deserialize. And Unity gives this great feature that you can edit them like a mono behavior. When you add fields, then the Unity editor will make them display, and you can also override the fields with your own code and everything. This is pretty much the same as the default Unity editor for mono behavior, but for objects that are basically serialized, deserialized. There are many ways to use this object, and the way we use it here is one way. And the way it works for scriptable objects is, let me open it real fast. We have here scripts, scriptable objects, and then we have item data. And in item data, we say we have a display name, we have a tooltip content, which is multi-line 10, so at 10 lines multi-line by default, and we have our rarity anim that we can choose from how rare this item is. And if you click on one, or if we see it here, then we have our display name, tooltip content, which is 10 lines, and our rarity. We can enter more than 10 lines, it's just how big Unity will make the box. And if we click on the item below here, you see on the right side that is pretty much the same editor. So also one thing that you can do, which makes it pretty easy to work with scriptable objects, you can create asset menu. File name is basically the default file name, and kdspath/create item is where we get to. So when I press right click, I have create kdspath and then create item, and then this will create a new item. I can rename the item. The name of the item is actually the item ID, so when we want to have coin, then we will add coin also. that is possible. But let me remove that. So one way to make files loadable in Unity on runtime is to put those files in this resources folder. This resources folder is at runtime available to load the data from. And let's take a look how we will load the data, because currently you could just click here and edit the data in the normal editor, and we want to load this data. And if you remember, our item provider was pretty empty in the last video, but we prepared the item provider to get the name and everything. And what we want to have now is basically a dictionary with the ID of the item and the item data as value. This way we can really fast access. And then our functions get name. We'll check if an item with that ID exists. If that's not the case, we return question marks. And it's better to return something than to return an empty string for debug purposes. Empty string always looks a little bit broken, if you ask me. And then we will return the display name. And for rarity, same deal. It's common if it doesn't exist, else we return the rarity, and here also question marks for the content, or we return the tooltip content, and we do our replacing stuff for rarity, color and everything. That's what we had in the last video also. But the tricky part is how to load the item data, and Unity API makes it really easy. We have resources.loadAll, which basically loads all. You have to check if that might be too slow, if there are too many items, but we will deal with that when that's the case. Because honestly, I don't know how many items we can have till it becomes a problem. And then we have to give the path in the resource folder. And our path is items, so we have resources, items, and everything is in there. And then Unity does the heavy lifting of loading all the files that we have, and items will contain all the files. Then we clear our dictionary, we go through the items and add them to our dictionary. By .name is actually the file name, which is our ID, so flower and test. And then we add the item. And that's how the item provider works. That's pretty much it. Now you will be wondering why I return the items here, but that we will get to. Because item provider itself doesn't need that, but I was a little bit lazy. So how do you write an editor like this? We already did that. We have this behavior graph editor, if you remember that one. It's a long time ago, but we did an editor. But for this editor, we just inherited from Unity Graph Editor, which gives us the whole graph capabilities. But this one is a little bit different. First of all, we want to use UIToolkit. The great thing about UIToolkit is that if you go to Window UIToolkit Debugger, you have a debugger, and if you're used to web development, then the debugger is pretty close to what the browser gives you in web development. We can select, for example, item editor window, which is basically our window, and then you can do pick element, and you can pick the element that you want to modify or find out, and then it will show you on the right side all properties that you could change for this element. And if you change them, then it should change them on the fly. Yeah, maybe a property field is not the best example. So now the text is red. And you know the name of of the properties, which is quite important. There's one important thing when it's inline, then it's defined by code, and it's pretty hard to override that via CSS, which we will look into now. But for the other ones, which are Unity style sheet or inherited, it's quite easy to modify that. So defining these properties, like I said, inline is defined in code, which makes it hard, for example, to change the height for one object. Let's say we want to have a 10, which is too small, but just maybe 50. Maybe if we want to have it smaller, then this field can't be overwritten by a style sheet. So how does a style sheet work in Unity for this editor, so we can modify those files? We have an editor folder. It's really important that we name the folder editor, because this will not be in the runtime of the game. This is just compiled in the editor with the editor assembly. The advantage of that is that we can leverage the editor namespace, and that's what we do. There we have 3 files, and those 3 files is what we talk about now. First of all, we have a style sheet. This one is the style sheet. And if we open the style sheet, it's pretty much like CSS. So we have box here, and box defines an object type. So every box that is in our layout will have FlexGrow1. The same goes for template container, and the same goes for list view. Those items could also have class names, which is basically like CSS classes. And then you can have here class name, and then right here the properties like height, 50 pixel, and something like that. And it also can define by ID with the hashtag, which is pretty much the same like CSS. And to apply the style sheet on objects, what we need is some kind of layout definition, which is pretty much like HTML, and this is what the other object here is. And this is the HTML of the Unity editor. So when you create a new one, the top one is given, and then I added a list view with the name item list, and a box with the name item, and then another box with the name item info. This is everything we need, and the code will render in item info, our Unity editor basically. What we can do with that is then this box here applies to every box because it applies to the type. We could also do hashtag item, then it just applies to this box, and we could also do comma hashtag item info, then it will apply to both because a comma will be multiple. But since we have so little of them, we can just do box, which is fine. And this will modify the properties that we see here with the debugger. And there we have a box, and the box will have FlexGrow1, which comes from our style sheet. And here at the top you see the style sheet, and also what you see here are the matching selectors. Since this has the class Unity box, a .unity box would also apply for that, and our box, which is in our USS, which is the style sheet. To create those files, you can just right click, create UIToolkit, then you have style sheet, and you have UI document. Those are the 2 files. One is the style sheet, one is the UI document. Now the question is how does Unity know that it has to use this style sheet and that you want to use this document in your editor window? That's where our editor window CSS will come in handy. Sometimes you have problems like I have now, which is good to show. For example, when I'm in Visual Studio, he has some issues with compiling the code. So that's why some things are red when I use Unity stuff. And I don't see a attached to Unity button. That means Visual Studio is not really sure if this is a Unity project. So if you're missing the button and you want to debug, it's really annoying. And sometimes Visual Studio has this problem here, especially if you use Visual Studio without Unity like we use for our backend. To fix this really easy, what you can do is you can go to Edit Preferences, and then you just press Regenerate Project Files. What Unity does is it regenerates the project files like the bottom says, and when you reopen your project, then everything should be back to normal. So we have the attached to Unity button again, and our code doesn't have everything red in it, because Visual Studio now understands that this is a Unity project. Don't ask me why it's here broken, but this is one way to fix it. So first of all, in our editor, we inherit from editor window. This is what makes this an editor window. And then we create a menu item, KDS based item editor, and this has to be a static function because it's a menu item. Then we get the window with get window item editor window, which is the reference to our instantiated window. Unity will instantiate that if there is none. Since we don't want to have 20 editor windows, one is enough for us. Then I set the title, and I set a min size to 800, well, 600, to 800 to 600, so that we see the window. And after that, the window is created if none doesn't exist, and then the title and size is set. So when I press item editor at KDS best, then the item will be set. It didn't do it because we used get window and there was already one. So that's what it does. And then we can show the editor, and it's empty. Let's remove this code real fast. So when you just do those lines, then it's empty, even though we have defined those files, but we need to tell Unity how to use those files. And the first one is loading the UXML, which is basically the Unity HTML, if you want to call it that way. So you load it with asset database, load asset at path, visual tree, and then you can give the full path. You could also load it with resource load and so on if it's in a resource folder, but usually we don't want to send those to the client, those HTML files, because this is an editor anyway, so it's not client displayed. But you load the visual tree asset, which is this HTML file, and then you have to clone it. So we clone it, and if it's cloned, then it's a template container. And then we can add this template container to our root visual element, which is basically the root HTML tag if we want to stay with HTML. And then this HTML or UXML that we defined is displayed. Let me show you how this looks like. You see nothing, but a trained eye will see here some kind of lines. And the reason for that, if we look into the debugger, that there are our items, but our layout is not defined. And if our layout is not defined, it will pretty much display everything depending on its inner content. And since we don't have any inner content, it will display it like that. And that's not how we want to lay out our things. So in our style sheet, we have defined our layout. And then we load the style sheet the same way. The style sheet doesn't need to be cloned. Then root visual element dot style sheets, and we can add our style sheet. Pretty simple. And when we do that, then our layout is defined. We didn't even have to close. Now we have on the left side the list, and on the right side we have our editor, but nothing is in here. So let's really fast look at the style sheet again. So our list view has a width of 250 pixels, and the text inside the list view is middle center. This is inherited below, so items within the list view will inherit that from the outside object. And then we have our box and template container flex row with a flex direction row. What this means, it means that objects we add will be on a horizontal manner. So the first one is on the left side, the second one is right next to it, and if we add more, then more will be added right next to it. And since the box is flex row 1, it means it will try to get the full space that is available to it. And our list view is 250 pixels. So if we look into our layout here with the UIToolkit debugger, then we can see that our template container is flex row and it's flex direction row. So first thing added is on the leftmost side, that's our list view, and second thing added is on the right side next to it. And if we add more, it will be on the right side. Pretty much like a horizontal layout in Unity. And since the list view is 250 pixels in width and the box is gross, the box will take the rest. So 250 pixels for the list view and the box will take the rest. It doesn't matter how I scale it, the box will take the rest of the space. Because of flex row 1. And the template container is also flex row 1, so the outside template container will take the whole space. And that's our layout done. So now what is missing is, first of all, on the left side, the list view. So we have also called create item list view on enable, where we do everything. And first of all, we need to find all items that we want to display. And there are multiple ways to load all resources of one scriptable object type. But since we have already our item provider, which loads them, I could reuse this function and just return the data for us. The great thing, if this function finds the data, then we know in one time the game will also find the data. But there are two different ways, which I want to show. One is, in asset database, you can use find assets, and then you can do t double dot for type, and then the type. For us, the scriptable object type is item data. And then you get all GUIDs of all items the asset database knows for item data. Then we can create an array or a list, it doesn't matter, whatever you like. And then we traverse the GUIDs, and there's an asset database GUID to asset path, which turns the GUID to the path where the asset is is available, and then when we have the path, we can do asset database loads asset path. So this is another way to do the same thing. Another way also would be resources load all, which is basically what our item provider does. And I like this more because this is how the game in the end will load that. So when the editor displays it, we know for sure that it will be also displayed in the game. So let's ignore those lines for now and just do the top line. So we get all items. Then we get our root visual element and we query for a list view with the name item list, which is exactly our list view. Since we only have one, we just get the first one. That's how we get our list view from our HTML object or UXML or whatever you want to call it. And the list view has a make item. This one could also load an UXML file and everything, but since we just want to display a label with the name of the item in it, we just return new label. And when an item is binded to this object, then bind item is called, and it will give us the element, which is basically what we return here at make item, and it gives us the index of the item source, where which item this label or this item should be displayed. And since we just return a label, we can do element as label because we know this is a label, and then we do .text to modify the text of the label, and then we set it to items, then I, which is the index, and then the .name. So we want from these items the index I, and then we want the name of it, and that's what we display. What we also could do, we could here do item list item source, but then we also have to convert that again because this is a non-typed list. We have to convert it again to an item data, which is not a big deal, but sometimes it would be cleaner to just use item list stuff in where item list is used, because they could desync, so this variable could be not set to item source if you have a more complex source code. But for our case, it's always the case. So we go the easy route here. And if we have that, then we will have flower and test in our list view. So now when I select them, nothing happens. So let's do that. First of all, we want to have selection type single because the list view will support multi-line, multi-selection, but we don't support that. And what happens when something is selected? Then item list on select change is called. We traverse through the items, which since it's single select is just one item, so this is called only once. And then we query again, this time for a box with the name item info. Then we clear everything that is in the box, so it gets emptied. And then we do some Unity magic, which I want to explain. First of all, we create a serialized object of our item data. Item is our item data. So when I change the serialized object, Unity will save this information back to the scriptable object, which is great for us. And with this, we can create the default Unity editor properties if we want to. And that's what we want to do for now. So we get an iterator, which iterates through all properties. And it works like that. You get the serialized property, and then you can, via next or next visible, you can traverse through the objects. Interesting enough is that we do next through, and the reason for that is not obvious. So Let's debug this code real fast. So when we select this is called with one item, let's just start at the top, why not? And press attach Unity. So debug is attached, so when something happens here, then it will trigger the debugger. You can actually debug Unity code. I founded some streamers and helped them on Twitch where they're developing for Unity, which didn't know that you can actually debug Unity code. Then we get an enumerable, like I said, it's single select, so there's only one object. And we got our scriptable object here. And we get our box, which is just a box. We clear it, and then we create a serialized object from our scriptable object. And then we get our property iterator. And the first property this displays, or this is bound to, is the base object. And what item property next true does, the true means go into the children. Then it goes one property down into the property tree, into the children, and after base it is hidden object flags. And since we don't care for that, we directly skip this one. And after we skipped the object flags, we will be at mscript. And mscript we display, but we set enable to false. And then we bind that property. So this creates the default Unity editor property field. We disable it in this case because it is equal to mscript. And then we bind this to the serialized object. What this does is it creates the field, and if the field has changed, then it will write back to the serialized item that the field has changed, and we disable it in this field. And then we add this field to our box, with the name item info. And then we go to the next field, and vice versa, and do that. And we don't go into children. If you don't go into children, Unity will render the fields, the children fields for us. And we don't have any children's anyway. And that's how those items are displayed. This is the mscript one, which is disabled. And then we have the other ones. In the default Unity editor, if you compare that, it is the same. So we basically have written code which the editor also does. But we could modify it. For example, we could add a button to the right here and display test or display this tooltip value, but we will later in the way future, which is not interesting for now. If we want to implement multi-language, it would be great to have a button here where we can select the English text. The English text is displayed, but the language text is actually serialized into the object. And later in our game, we can convert this language text back to the actual text that is displayed. And then it will look up into English, German, or whatever language we want to implement file to what this tag means in this language. And these are capabilities that we will be able to add to this editor window. That doesn't mean that this is always the best idea to do, because we could also add these capabilities here. But we will be able to have way more features in this editor window, and I really wanted to show how to write those editor windows. Because normally when I wouldn't do an editor window like that, for me an Excel file would be great enough. But still I wanted to show you how this new UI API from Unity works. I wish you all a great weekend, and I really want to thank my patron Julian. Have a good day. Bye.